So next one is a series motor runs at 900 revolutions per minute when the voltage is 420 volts and the current is to be drawn from the supply is 40 amperes. The armature resistance is 0.3 ohms. Series field resistance is 0.2 ohms. Calculate the resistance to be connected in series to reduce the speed to 720 revolutions per minute with the same current. So in this also we are considered as a two cases. Without adding resistance is to be connected in series. So previously, we are connected as the parallel with the series field winding. But in this case, series with the series field winding with the same current, but speed is to be reduced to 720 rpm. 720 rpm. So series motor speed is equal to 900 revolutions per minute. So input voltage V is equal to 420 volts. So armature resistance is denoted by RA. RA is equal to 0.3 ohms. So another one is series field winding. RSE is equal to 0.2 ohms. Some amount of resistance is to be added. Corresponding speed is to be reduced to speed reduction to 720 revolutions per minute. Okay, so in this also we are considering two cases. So one is the input voltage 420 volts. So armature resistance and RSE. So first condition we can find out the back EMF. E1 is equal to. So all of you know the general series motor, which is equal to series. Another one is armature, which is equal to armature. So this is the external resistance. So which is equal to input voltage is equal to 420 volts. So which is equal to 420. So E1 is equal to V minus IA into RA plus RSE. So in these equations, current drawn from the supply is equal to 40 amperes, which is equal to 40 amperes. 420 minus armature current is equal to 40 of armature resistance 0.3 plus series field resistance 0.2 is equal to 400 volts. So corresponding without adding resistance, corresponding back EMF is to be generated by the series motor is equal to 400 volts. So second one is, so we can find out the E2. So because of speed is to be reduced, yes, our speed is to be directly reduced to 900 to 720 rpm. So E is always directly proportional to speed. So because of back EMF is always directly proportional to flux into speed, flux is always constant. So which is equal to E1 by E2 is equal to N1 by N2. So we can substituting both the equations. E1 is equal to 400 divided by E2 is equal to 900 divided by 720. So by simplifying this equation, so E2 is equal to 320 volts. So in this, so this much amount of resistance or voltage is to be presented when the external resistance is to be added, because of when we are considered as a output speed, or when we are adding the some resistance is to be connected in series with the series field winding, corresponding speed of the motor is also reduced to 720. So in this instant, so which is to be generated, the back EMF is equal to 320 volts. So another one is, so E2 is equal to or back EMF of second condition when we are adding the external resistance, which is to be denoted by R, which is to be denoted by R. Okay, so this value is to be calculated. This is the unknown value. This is the unknown value. E2 is equal to V minus IA of. So because of IA is same current. So in that also, so 720 revolutions per minute with the same current. So IA is same. So it is equal to RA plus RSE plus unknown resistance, which is equal to R. Unknown resistance is equal to R. So E2 is equal to 320 is equal to supply voltage. So 420 minus IA is equal to 40 of RA plus RSE. RA is equal to 0.3, 0.3 plus 0.5 plus R. Okay, so in this, so 40 into 0 which is equal to 0.2, 0.5 plus R is equal to 100. 0, 0 gets cancelled. So 10 by 4, 0.5 plus R is equal to 10 divided by 4 is equal to 4 2s are 2.5. So R is equal to 2.5 minus 0.5 is equal to 2 ohms, is equal to 2 ohms. So whenever the 2 ohms of resistance is to be connected in series with the series field winding, the speed of the motor is to be reduced to 900 rpm to 720 rpm. 720 rpm. So this is the addition of resistance. Previously we are discussing about the parallel connection. So this one is the series connections. So in this we can add the resistance is to be connected in series with the series field winding. So corresponding speed is to be reduces. So because of current is directly proportional to back EMF, so which is also inversely proportional to the speed. So that's why current is to be reduces, speed is also reduces. So that is the third problem. Okay, so series motor runs at a speed corresponding which is to be reduced to the some speed. In that instance also we are calculating the unknown resistance. So by using this procedure.